right, so in this video we're going to talk about Lesson 2, arithmetic sequences. So we'll talk about them in general a little bit and then look into some problem solving. And an arithmetic sequence is a sequence in which you can add the same number each time to find the next term. So when you think back to Lesson 1, there were some of those sequences where you identified that you could add the same number each time to get to the next term, or subtract, and those are arithmetic sequences. The opposite of an arithmetic sequence is a geometric sequence, and a geometric sequence is one in which you multiply the same number each time. So the key thing about an arithmetic sequence is that you're adding the same number each time in order to get the next term in the sequence. That number that you add each time is called a common difference. And that common difference can be either negative or positive. So example 1 says find the first term and the common difference of the following sequences. So the first term really is as easy as you think it is. The first term is just the first term in the sequence. So for this sequence, part A, it's going to be 34. Now the common difference is what you add every time to get to the next term. So if I'm looking at this sequence, I've got 34, 36, 38, 40, 42. It's pretty easy to recognize that I'm adding 2 each time. So my common difference there is going to be 2. If that sequence is a little bit more complicated, the way that we can find our common difference is doing u of n plus 1 minus un equals d. And that's a really fancy way of saying that we take one term and we subtract the term before it in order to get the common difference. So for example, we could take 36, subtract 34 from it, and that would give us our common difference of 2. And we can do that with any 2 terms that are sequential to each other. So another example would be I could take 40, subtract from it the term before 40, which is 38, and that gives me my common difference of 2. Looking at the next sequence here, I've got 3, 2, 1, 0, negative 1. Again, starting with my first term, it's 3, first term in the sequence, pretty straightforward. My common difference here is I'm going down by 1 each time. So my common difference is going to be negative 1. Pretty easy to recognize again, but we can test out our common difference here by taking one term and subtracting from it the term before. So 2 subtract 3, which gives me negative 1. And that's going to work for any 2 sequential terms in this sequence. So I could take 0, subtract from it the term before, which is 1, and I get that common difference of negative 1 again. The reason that we look for the common difference in the first term is to put together something called a general term formula. So a general term formula is a special equation that lets you find out some information about the sequence. So it can let you find the value of a given term. So for example, we could look at this sequence B, 3, 2, 1, 0, negative 1, and using the common difference in the first term, we could find the value of the 100th term, the 1000th term, the 198,000th term. So we can find the value of any term in that sequence using the general term formula. We can find out the term number of a given term. So we could say, okay, so for sequence B up here, we're going to have the term negative 9. Let's find out what term number that is. So how many terms do I have to have in order to get to negative 9? And then we can also figure out whether or not a given value is part of the sequence. So the general term formula for an arithmetic sequence, and this is given to you in your formula booklet, is un equals u1 plus n minus 1d. So what that means is that the value of a given term is equal to the value of the first term plus the term number minus 1 times the common difference. So let's take a look at what putting together a general term formula is going to look like in real life. So let's start with example 2, part A. I've got 34, 36, 38, 40, 42. So my first term is going to be 34. My common difference there is positive 2. I'm adding 2 each time in order to get to my next term. So my general term formula, un equals u1, so 34, plus n minus 1 times my common difference, which is 2. This is okay for my general term formula. I'm just going to clean it up a little bit by distributing this 2 into my bracket and then collecting like terms. So I end up with 34 plus 2n, subtract 2. I've got some like terms here with the 34 and the negative 2. So when I clean that up, I end up with 2n plus 34 minus 2, which is 32. And there's my general term formula. un equals 2n plus 32. And that would let me find the value of any term in here. So just to check, I know that the value of the fourth term is going to be 40 based on this sequence. So in my head I could say, okay, well 2 times 4, my fourth term, is 8 plus 32, gives me 40. So I know I'm on the right track with that general term formula there. Let's try example B. So I've got 3, 2, 1, 0, negative 1, common difference of negative 1, and a u1 of 3. So the first term is 3. So my un equals u1, 3, plus n minus 1, onto my common difference, which is negative 1. Cleaning that up a little bit, I distribute this negative 1 into my bracket. I end up with 3. Negative 1 times n is negative n. And negative 1 times negative 1 is positive 1. So my general term formula here, un, is going to be negative n plus 3 plus 1, so plus 4. I can check that. Let's pick a random term here. Pick the fifth term is negative 1, so n equals 5. I've got negative n, so negative 5 plus 4 is negative 1, which corresponds to that term, so I know I'm on the right track. Alright, so example 3 is very similar. First question is asking us to find the general term formula. So I know for my general term formula, the two pieces of information I need are u1 and d. So u1 here, my first term is going to be 19. And my common difference, I'm going from 19 to 25 to 31 to 37. So I can pick two of those terms, maybe 31 and 25. My common difference is going to be 31 minus the term before it, 25, which gives me a common difference of 6. So remember, the general formula for a general term formula is un equals u1 plus n minus 1 d. So un is going to equal 19 plus n minus 1 times my common difference, which is 6. Clean this up a little bit. I'm just going to distribute the 6. I end up with 19 plus 6n minus 6. So un equals 6n, and 19 subtract 6 is positive 13. 6n plus 13. Now, to find the value of the 10th term, I'm looking for the value of u10, and I know I'm looking at the term number 10. So n equals 10, and I'm looking for the value of u10. So what I'm going to do is use my general term formula. I've got u10 equals 6 times the term number, 10, plus 13. So 6 times 10 is 60 plus 13 is 73. So the value of the 10th term there is going to be 73. Now I'm being asked to find the term number for 79. So what this means is that 79 is a term in this sequence, and I have to find out what the term number is there. So my un is 79, and I don't know n. So I've got 79, again using my general term formula, equals 6 times n, my unknown, plus 13. I've just got to solve for n here. So I'm going to subtract 13 from both sides. I end up with 79 minus 13, which is 66. equals 6n. Divide both sides by 6 here to isolate n, and I end up with n equals 11. The 11th term is going to be 79. The last question is asking us, if we kept expanding this formula out, would I eventually get to 114? So let's take a look at that. In order to solve this, what we need to do is set 114 for un, and then solve for n. So I know the value of my term is supposed to be 114. If I solve for n there, what do I end up with? I end up with 114 equals 6n plus 13. I'm going to subtract 13 from both sides. And I end up with 101 equals 6n. Dividing both sides by 6 there, I need to figure out if that 101 is divisible by 6. So if you can't do that in your head, that's something that you might want to look to your calculator for. Is 101 divisible by 6? So take a minute to think about that there. And then think about the repercussions of your answer. So if 101 is not divisible by 6, then what does that mean for our answer? If I divide 101 by 6 in my calculator, I end up with n equals 16.83 repeating. So what that means is that 114, this term, is going to be somewhere between the 16th and the 17th term, which means it's not a term in its own right. So what you've discovered there, because our n value is not an integer, is that 114 is not a term in the sequence.